Okay, here we go. Here's our last property. If you're taking the sum as k goes from 1 to some number n of k squared, there's kind of an interesting pattern to that. Here's what it ends up being. It ends up being n times n plus 1 times 2n plus 1 all over 6. And we'll do an example first, and then I'll show you the proof. All over 6. I know. Where does that come from? So, for example, suppose you were just looking for the sum as k goes from 1 to, let's say, 4 of k squared. And if this were yesterday, you would have just written this out, right? 1 squared is 1. What's 2 squared? Tim?
4.
Yep. 3 squared, Luke? Alan, 4 squared?
60.
Good. And if we add all of these up, that's going to give us 5 plus 9 is 14, plus 16 gives us a grand total of 30. But now let's test this equation. If we were going to test this equation, Marie, what is it that we're going to plug in for n?
4.
And then n plus 1 will be what?
5.
And what about 2n plus 1?
9.
All over 6. And let's see, we can do a little bit of canceling. 3 goes into 9 3 times, 3 goes into 6 twice, 2 goes into 4 twice. So in fact, that does give us a 30.